So here we are with 3.12, solving linear systems. This time we are using the method of elimination. Okay, so remember we have three methods, and this is the third and final method that we're learning for solving linear systems. And remember, a linear system looks something like this, where you have two linear equations, and you're trying to figure out where they intersect. That's what we're trying to figure out. So this new method is called elimination. All right, so elimination. What does the word elimination make you think of? Well, to eliminate something is to get rid of it, right? So elimination is when you get rid of one variable. Okay, so notice, when I look at this type of a problem right here, how many variables do we have in each equation? We have two variables in each equation. We have an x and a y. So the plan would be to get rid of either the x or the y. So let's take a look at this. Problem number 2. Solve the following system using elimination. All right, so what's our plan going to be? I'm going to take off the sticky note. Yeah, okay. Step 1. Line up the equations. What do I mean by that? Well, I want to have the x's first, then the y's equal to a number. Oh, look at these. They're lined up. The x's are lined up together, the y's are lined up together, and the numbers are lined up together. So for an example of when they would not be lined up together, here are two examples of when they're not lined up together. So if I maybe had 2y equals 3x plus 4, and then 2x plus 3y equals 5. Notice, for this system, my x and my y's are all on different sides of the equal sign here. But this one is lined up nicely. I have my x values, my y values, and my 5. So for this problem, what we'd have to do is move the x to the other side. So we'd end up with negative 3x plus 2y equals 4, 2x plus 3y equals 5. So now I have turned this one into the correct form for our type of elimination solving. The x's are lined up, the y's are lined up, and the numbers are lined up. Right? So for the problem we have, though, it's already given nicely lined up. All right, so that part is done. Step 2, choose a variable to eliminate, x or y. All right, so the plan when you're choosing a variable to eliminate, you want to look at the ones that have the smallest numbers in front of them. Okay, so if you look at x, that has a 3 and a 2. But if you look at the y's, notice they just have a 1 in front of them. So for me, y would be my best bet because the number in front of y is smaller. So for 2, instead of a hint, look for the variable with the smallest numbers, or coefficients. Okay, so that's the hint for step 2. All right, so what we've chosen is we're going to get rid of the y. So step 3 says match your chosen variable using multiplication. What do I mean by match? Well, I want the number in front of my variable to be the same number. So for example, if I had chose x to be the one we're eliminating, notice the x has a 3 and that x has a 2. These variables are not matched at this moment in time. But if I look at the y, they both have a 1. So actually, these variables are matched at this time. So I don't need to multiply them by any number to make them matched. So what if I had chosen the x's to get rid of? How would I make a 3 and a 2 look similar? Well, I could choose to make each of these become a 6. So if I multiplied this equation by 3, I would get 6x. And if I multiplied this equation by 2, I would also get 6x, which then means I would have matched my variable. But we have chosen to cancel y's. So we don't actually have to do anything to this problem because the y's are already matched. They both just have a positive 1 in front of them. So step 4, we're going to add or subtract our equations together. Let's see. If I chose to add my equations together, Remember, I'm trying to cancel out my y. So when I add, I have one y plus another y. That becomes a 2y. That didn't cancel out my y. My goal is to cancel the y. So we're not going to add. Instead of adding, we're going to subtract. And let's see what we get. So we will subtract to cancel the y's. Okay, so when I subtract, 3x minus 2x is going to become 1x. And then y minus y minus y is going to be 0. So plus 0 equals 6 minus 8 is going to be negative 2. So x equals negative 2. Oh, that was pretty quick. Remember, we're not done yet, though. This is a system. We're trying to figure out where these two lines intersect. So for my answer, remember, I want a coordinate pair. And I have just found the x value of my coordinate pair. So I need to go back and find the y value. How do I do that? Well, I know what x is. So step 5 says, sub your answer into the other equation. So I'm going to take this x value and I'm going to sub it into either one of these. It does not matter if I choose the top one or the bottom one. I'm going to go with the top equation. Might as well. Both of these equations, they both have small numbers, so none of them look better than the other. So I'll just go with the top equation. So here we go. We're going to find x to find, we're finding y to find y. I'll use the equation 3x plus y equals 6. And we're going to sub x equals 2 into this equation and solve for y. Okay, go ahead, pause the video and try see if you can solve for y. All right, subbing that in, so 3 times plus y equals 6. Putting in negative 2, because remember x equals negative 2, so I'm subbing that in. That'll be negative 6 plus y equals 6. Solving for y. Let's add the 6 to that side. So then y equals 12. All right, remember our answer needs to be a coordinate pair. So our answer is negative 2, 12. That is where the two lines intersect. Okay, so the elimination method, I think it's rather nice. Straightforward. I like it better than graphing. Okay, so we have one more example for this class activity, and that'll be it for elimination. All right, solve the following system using elimination. Okay, go ahead and see if you can solve this using the steps that I have. All right, so let's see what we have to do. So for the first step, we're going to decide, am I going to cancel out the y's or the x's? I think this time I'm going to choose to cancel out the x's. All right, so to cancel the x's, that means I need to match them. I have a 4x here and a 2x here. So how would I make them look the same? Well, if I multiply this equation by 2, then I would get a 4x. So let's do that. So I'm going to multiply second equation by 2 to match the x's. All right, so I'm going to multiply this by 2. Remember, you have to multiply everyone by 2. Each of these terms needs to be multiplied by 2. So we have 4x plus y equals 10. That equation has not changed. I didn't multiply it by anything. The bottom equation, however, becomes 4x plus 3 times 2, 6y equals negative 5 times 2, negative 10. All right, now take a look at this. The x's are matched, 4 and 4. So I need to decide, am I going to add these equations together or subtract them? If I added, I would get 4x plus 4x, which would get 8x, and that means I haven't canceled my variable. So I want to subtract them, because then I can cancel my variable. So 4x minus 4x, that cancels and becomes a 0, plus y minus, I'm going to use a different marker here. Y minus 6y, oh, it's a minus 5y, equals 10 minus negative 10. What does that look like? 10 minus negative 10? That becomes 10 plus 10, which is 20. All right, so 20. So if negative 5y equals 20, solving for y, let's divide both sides by negative 5. And I ended up with y equals negative 4. I remember, our answer is a coordinate point. So I found the y. How do I find x? Remember the plan? Take this value and substitute it into one of your top equations. I'll go ahead and choose the top equation. So to find x, we're going to use the top equation for x plus y equals 10. And we found out that y equals negative 4. So we'll take that value and substitute it in. So 4x plus our y value, which was negative 4, then we have 4x minus 4 equals 10. All right, solving for 4, we can add 4 to both sides to get rid of that negative 4. And then 4x equals 14. Divide both sides by 4. X equals, 14 divided by 4. Can that be simplified? Well, they can both be divided by 2. So 7 over 2. So our answer is going to be 7 over 2, comma, negative 4. And that is the point at where these two lines intersect. So that was the elimination method. The plan: identify the variable you want to cancel, multiply the equations by any number to match those and create the same number in front of your variable, and then add or subtract to cancel that variable and end up with only one equation and one variable, and solve. Once you find your answer, you'll sub that number back into any of the equations to find the other matching coordinate point. Okay, so you can end up with your coordinate.